Here's an integral that could be an easy contender for the final round at the MIT Integration Bee or a Putnam Exam. It's so hard that I would call it the integral from hell. First, you have to use some algebraic chicanery to get this integral into a more manageable form. After that, you have to wend your way through two separate integration techniques and evaluate the limit at the end. As always, you're welcome to give this problem a try if you dare, and when you're ready, join me for the solution. The first little trick is to add 1 and then subtract 1 in the numerator like this. The purpose of that trick was to split the integrand into two separate fractions. Of course, now the 1 plus e to the ax cancels on the left, and the 1 plus e to the bx cancels on the right, which simplifies rather nicely to this. So that was our first major hurdle, to get this into a form that is more user-friendly for integration techniques. Since this is an improper integral, we'll need to replace infinity with a dummy variable, say t, and rewrite as a limit. Fortunately, since both integrands are nearly identical, with the exception of b in the first exponent and a in the second, each one can be treated as a separate integral using the same integration techniques. Let's begin with a substitution. We'll let u equal e to the bx and v equal e to the ax. Then du will equal b times e to the bx dx, or bu dx, and dv will be a times e to the ax dx, or av dx. Finally, we need to adjust our integration limits to go from 1 to e to the bt for the left integral and 1 to e to the at for the right integral. When we insert all these substitutions, we'll get the following new integrands in terms of u and v respectively. Now we're ready for everyone's favorite integration technique, partial fractions. In this case, they're pretty easy to set up to solve for the coefficients. I'm only going to focus on the u integrand since we'll get the same result with the v integrand. We'll set it equal to a over u plus b over 1 plus u, where a and b are the coefficients we need to solve for. Let's combine fractions on the right side. And now we can set the numerators equal to each other and rearrange like this. Now we just equate the constants on the left with the constants on the right, and the u terms on the left with the u terms on the right. From inspection, we can easily see that a equals 1 and b equals -1. So now our integral looks like this. Since the integral of 1 over u is natural log u, 1 over 1 plus u is natural log 1 plus u, 1 over v is natural log v, and 1 over 1 plus v is natural log 1 plus v, we can finally get rid of the integrals and rewrite so that we can evaluate using the limits of integration. Let's use the following handy log property to simplify these expressions even further. Plugging in the limits of integration, we'll get the following. As t tends to infinity, the expressions in parentheses clearly go to 1, which means we're left with just a little bit of simplifying. Natural log 1 is 0, and natural log 1/2 is negative natural log 2. Now let's just factor out natural log 2. And we can write this expression as a single fraction. Bam! There's our answer. It goes without saying that if you got this correct, you know your integration. Did you do it differently? Let me know in the comments below. And as always, thanks for watching and see you soon.